Hi everyone, I'm Zoe. I'm focusing on Euler number today. Uh, we call this E after mathematician Leonhard Euler, born in Switzerland and died in Russia in 18th century. His discovery was and is very important, especially when you study about logarithm or exponential function in general. Okay, before we go and find what is the secret behind this expression of Euler number, just recalling this one, we talked about a compound interest when we had exponential growth. For example, we had an example about a equals to p 1 plus Rn, everything raised to RT. What was that? This is formula for uh, mm, finding something about the amount, the final amount after you have investment, the initial investment like P, and R was rate of interest, and T is year, N is the number of time in year that your money is compounded. Okay, we had this one, and I want to explain something about this. Just supposing P is just P, and R rate of interest is 100%, for example. Easier, okay? Okay, we want to know how many times a year is profitable most for a person that invests this money. Okay, if you think this once a year and annually you can get how much is going to be. After a year, after 1 year, you have your principal, the investment, 1 plus R is 100%, 100% in decimal is this. 1 times a year, 1 times a year times 1 is 1. Because T is a year and R is 100% is 1 times 1. Okay, how much we get? We get 1 divided by 1 gets 1 plus 1 gets 2, and 2 raised to 2 is gets P times 2. It means that your principal, this principal or investment, initial investment gets double, yeah? If compounding is just once a year, okay. How about twice a year, every 6 months, okay? 2 times 1, this is times 1, this is 2 times 1. How much is gonna be? It's gonna be 1 divided by 2 plus 1, and everything raised to 2 gets something about 2.5. Okay. People said, okay, if twice a year we had compounded, the money gets compounded is much better because 2.5 times bigger that principal. Okay, but how about the actually 3 times a year compounding? P1 plus over 3, how much is gonna times 3 times 1 year? It's if you calculate this one, gets inside the parentheses gets 2.37 something. Yeah, it gets a little bit bigger. Your money times 2.37 after 1 year, 3 times a year. Okay, how about somebody says, okay, why 3 times a year? We can do something. We can calculate to every day, 365. Okay, how much is going to be 1 plus 365 times 365 times 1? Yes, times 1. How much is going to be? If you calculate this one, it gets something about 2.61. You see? 2.37, 2.61. It's not too much change. If your money gets compounded every day. Okay, how about every second? Every second means your principal, 1 plus rate of interest over 365 times 24, and this is the day, 365 day times every day 24 hours. Every hours is 3,600 seconds. Yes? Raised to this number, 365 times 24 times this, times 1, because here is 1. Okay, how much is gonna be? When you calculate this one, you get this, your principal, the investment versus investment, times 2.71 45 something, because this is irrational number. Okay, you know, 2.61, 2.71 every second a year. Okay, people didn't know what happened if once a year the money compounded. It's very close to 2, and any second. This is not too much difference between these two. What was the secret behind this? But Leonard Euler, this Swiss mathematician, he discovered something. He discovered if we have this concept like this one, 1 plus 1 over n multiplied by n, 1 plus 1 over n, everything raised to n, how much is gonna be? If n gets bigger and bigger and bigger, it means that n goes to infinity. How much is gonna be? He showed that if n, the number of n, goes to infinity and gets bigger and bigger, this concept, this ratio, or this number, it gets closer and closer and closer to this amount. This is an irrational number. It means that never ends and never get as a block. 2.71828 something that, and forever. Why? He said, okay, if you get limit of this number, if you get 1 plus 1 over n, when n is 1, we calculated this one. This is a base. Here is base. Calculated 1 gets 2. Okay? When n is 1. Okay. When n gets 2, we had 1 plus 1 over n, 2, and 2 gets how much? This one gets 2.5. Okay, and 3 gets 1 plus 1 over 3, 2.37, and 10 we get 1 plus 1 over 10, something gets 2.5937 something. This is irrational number. And if n is 100, how much is going to be? 1 plus 1 over 100 raised to 100 gets 2.70481 something. And n, how about n is 1 million? Huh? What happened? Euler said 1 plus 1 over 1 million raised to 1 million. $2.71828 maybe 2 for something. You see? He claims that when we have this concept, the 1 plus 1 over n to the n, this is a base of exponential function, compound interest. This number, if n goes to infinity and get bigger and bigger and bigger and bigger, this base, this 1 plus 1 over n raised to n, gets just closer and closer and closer to 2.1718828 and something like this. This is the secret behind everything. We use this one. This is very important because when you study about any exponential function, exponent growth and exponent decay, you face to this number, because this number is very important about this. Okay, when you calculate the number, the growth of exponent growth of bacteria, when they goes just increasing function like this, the population of bacteria or culture of bacteria goes up. You use this one, E. And when you study or want to calculate about the decay, radioactive decay, you use this one, but other ways in decreasing. Okay, we have decay, but we use this number. This E, Euler number, is one of the important, the most important number in mathematics, and you're going to work with this one many times, especially when you go to start studying about logarithm or natural log and other things, because exponential function like this one, using this, when you graph this one, you see that the graph of E exactly is just inverse to log function. That's why this is very important. Okay, hope you like this one, and hope you find out why we use E. And next time I come back with another example of compound interest, not with this one, because this formula very useful when you have the number of compounding, the compounding, how many compounding you have. Just this is answer. How many compounding you have in a year, 2, 3, or 5, or any second. But sometimes this exponent growth happens every second or every moment. We say continuously. This is not continuously, because this number depends on this number. When the growth is continuously, we use E instead of this base. Okay, when you calculate the population of bacteria, you use E instead of this parenthesis, because bacteria, the number of bacteria grows every second or every moment. Okay, and radioactive decay too. When you have a radioactive element, it decays any moment. That's why we use E here. Okay, I come back with another example, and don't forget to subscribe the channel if you think this is useful for you, and share this one with your friends and other students. Goodbye.